Okay, we will be talking about NLP basically in deep learning, and it's going to be highly practical talk. So I will give you a lot of like code examples. So it's like a beginner level talk. Some of parts might be intermediate, but the aim of this talk, like once you go back today, so just start playing around with the tools and techniques that you're going to see during this presentation. So my name is Umit, and I'm a member of a team called IBM Data Science Elite Team. We are a team of global experts. We are helping clients with the use cases around machine learning and deep learning. A lot of interesting stuff going on, and we have all the teams from all the way from data engineering, data science, application development, and production engineering. So we are covering all machine learning lifecycle. Of course, enjoying PyData. It's always nice to be with all of you here. A lot of smart eyes looking at me. It's a bit intimidating, but I'll try to do my best to meet the expectations. And I have a Twitter account. I'm just picking a lot of, I think, quality content for the people who would like to get into the field. And this is one of the books that I'm co-authoring. I asked the publishing house, and they provide you just for this event like 15% discount. I don't know if you wanted to use it. It's valid till the end of this month. So go and check it out. We are talking a lot about automated machine learning pipelines, especially in Python. So let's start. The agenda will be like this, like 5 folds. I'm going to talk about the persona called Quant. How do they use NLP, what they are trying to do, and we'll also get into a bit of deep learning. I will be explaining the recurrent layer. And I will share some application architectures that you can play with. So the Quant is a multidisciplinary guy. So he knows a lot about math, stats, and he merges all of those theory with the computer science. And here is the sample job advertisement. Yeah. So we are looking for an advanced training, strong knowledge of machine learning, time series analysis, and pattern recognition NLP. Of course, the research experience and also strong soft skills, because these guys also need to communicate their results to convince their executives just to put some money behind these strategies. And they also need to be familiar with concepts like efficient market hypothesis, adaptive market hypothesis, and some very popular analysis techniques, algorithmic trading and sentiment analysis. For those who do not know what is efficient market hypothesis, so it's basically markets are sort of random walk, so it states that it's impossible to predict the future behavior looking at the past data. And it's like a more than 50 years old theory, and we recently have like adaptive market hypothesis. It's just including a lot of, let's say, behavioral parts when you're modeling the asset prices, right? And these quant firms could be like small quant shops, mid-size, big-size quant shops. Like it could be like 5 or 10 people running a small hedge fund, or it could be all the way up to like Goldman Sachs, I don't know, investment, FX, VP, I don't know, whatever those levels that you call, it goes all up the way to the sophisticated levels of investment strategies. And these are very particular examples because Renaissance technologies are, they have a staggering returns for the last, let's say, 40 years. Especially even in the crisis times, these guys are able to generate huge lump sums of money when everybody is losing and being out of the business. And the second example I'm giving, long-term capital management. At the end of 90s, these guys miserably went bankrupt, and they had like Nobel Prize winning economists on board and a lot of smart PhDs. So I'm trying to explain how much like deep thought going into these kind of algorithms, and the process of building these is like highly sophisticated. You need to think every aspect of your algorithm before really deploying those to the production, right? And how it's being used. NLP is usually used in sentiment analysis and training, so it could be about particular company, it could be about specific market index, right? We would like to train that sentiment. There are third-party data providers. You can, I don't know, do a simple GET request to their API, and you will be getting a simple sentiment score about Google or Microsoft, and you can start building your strategies on that sentiment. And these are example data sources: exchanges, regulators, corporations, third-party data vendors, news agencies, and governments, right? couple of examples for each of them. You guys are probably familiar with scrapping. Yeah, you can scrap a lot of data from news agencies like Reuters, Bloomberg, Wall Street Journal. You can get annual reports from company websites. You have announcements, filings. Of course, you can get data from brokers. And most recently, a lot of research to Twitter as a main source of data, right? Because it's easy to search those hashtags and just start building some strategies. And you have some market data, because at the end you would like to connect these textual information with the price movements. So every time you receive a new textual information, you would like to predict the up or down or steady or directly the number, like the percentage change for a given asset. And how many of you done some, I don't know, trading before, like personal trading? Some of you, okay. And how many of you familiar with NLP? Cool, nice. So we are mostly developers. Is that a correct assumption? Developers? Perfect. So, great. Let's look at how do we process textual data. So for machine learning algorithms, we need numerical inputs, right? So numerical vectorized inputs. So, and we need ways to convert those textual data into numbers. And then we need to reduce their dimensionality, because if you think about a typical vocabulary, right, you have thousands of words, and we are talking about very sparse matrices here. So it's hard to work with. So we have a lot of dimensionality reduction techniques. And of course, like what kind of numbers that we're going to put corresponding to each word or sentence or document. So we need to really decide on the method, whether it's called binarization, TF, IDF, I'm going to introduce, or distributed representations recently, which are more popular. This is a simple bag of words example. So you have a corpus, like body of text. So I have 3 different sentences here. You can think of them like as a different articles, like some equities, some index-specific information, and US stocks, etc. What we can really do, use a simple, the feature extractor. This is a count vectorizer. It's you use the stop words from English, so it will remove the stop words, all the like A and B, that kind of words. And then once you invoke the fit transform based on a text, it's going to do some tokenization. It's going to split sentences up its words, do some normalization, and it will give you a simple vectorized form like this one. So here you see the pandas. So for every word, you have the number, corresponding number, and that number represents the frequency of occurrence in for that word in a given sentence. So this is the simplest way that you can go about it. Even if you don't know anything about the theory, that might be the method that, when you think, okay, how do I turn this into a numerical input? So you can do something like this. And this is called unigrams, because that includes like simple words. And this doesn't capture the phrases or multi-word expressions, right? So it doesn't know anything about the context. What is the word before? What is the word after? You don't have that information here. So that's why the next step that they did is something called n-grams. And n-grams is like, depending on the n, that it can create word pairs like this. So we are looking at a bigram here for the example sentence. So it's like iteratively creating those pairs. And now I have kind of like contextual information because I have the pair of words there. And then here in the same data frame, now you see the pair of words and their frequency of occurrence. One thing you can do is to binarize this. So you can turn this numerical values to 1 or zeros, right? So you don't write the frequency of occurrence, but whenever a word occurs more than 1, so you just put it as a 1. Whenever it's not, it's 0. And by this way, now you can measure the similarity between documents, right? So you can do a simple subtraction, the second sentence from the 1, and it's also like simple sum after that. Then you can develop some simple measures to understand how each document is similar to each other. Of course, very basic, but It's a point to start. We have something called TF-IDF, and this also measures the, let's say, the relative importance of a given word. And the idea is following. In every document that I'm working with, if there is a word that appears in every document, then it must be very common, hence it's not important for me. So it's not, that word is not, let's say, as a defining characteristics of a given document, such as European here. So I have European in all the sentences, therefore the European is probably not something is important. And if you think about the different industries, so if you have a text from aviation industry and healthcare, probably the terms that are coming from healthcare will be unique to documents that are in the healthcare, so they will have like higher weight, and the common ones will have the lower weight. And here you see the European has lower weights than the other words, right? So it has like 0.2 something. And then the others have a higher because European is like frequently used, and that's the idea behind. And most recently, right, in 2013, they came out with something called word-to-vec model. A team at Google Research came up with a neural net architecture and tried to have these encodings. And one of the advantages of word embeddings are they are dense representations. So previously I had a vocabulary of 5,000 words, and majority of them were 0, right? So it means like 5,000 dimensions to work with. Now using this technique, I can predefine the number of dimensions that I'm going to have. Let's say I can put 300 there, which is a commonly used, like tested number, so that I can have 300 dimensions for every word that I have in my vocabulary. So if I have a corpus like this, and if I wanted to encode every word in the sentence, what I can do first to tokenize my sentence, so I just split that sentence into the words, and then what I can do is to train a word-to-vec model that you see. So it's the library Gensen, by the way. It's a great library. And then I can basically put some parameters and then train this model. And what it's going to give me, so I choose 15 for the size. So now for every word, I have a vector to size 15. So I'm going to have these floating point values, right? And so 3 words, 3 vectors of size 15. And having these vectors now allows me to measure the similarity between words. Now I can put the word price, then I can get the 10 most similar words to the price, or investor, or a stock. So even, I mean, of course, this is a toy example that the things won't be really meaningful, but if you have a huge collection of text documents, and if you train this model, and these embeddings will be your domain specific, right? If you're working in a healthcare and if you collect a bunch of documents and apply this, and then you're going to have domain specific embeddings. And what you can do with it later to invoke this most similar words to the price, and you will get a bunch of words. Just because our example is a toy example doesn't give you anything meaningful, but what is better, a lot of companies are releasing their own pre-trained like word embeddings, right? So you have word-to-vec from Google, Globe from Stanford, and fast text from Facebook. And then you can download these embeddings, right? Now what I'm doing is just uploading, right? Sorry, I'm loading that word-to-vec model. And then I can use these pre-trained embedding. So I have commonly used words in the financial text, search, plunge, gain. Now I have the 10 most similar words. So how can I use this information, right? Because machine learning is all about creating your features. So we have seen some like n-gram methods, TF, IDF, and etc. So now I would like to enhance that feature set and put something more informative. And I can define a set of keywords. Let's say 10 words that are really important to that body of text. So it is almost like when I see those words, when I'm reading news from Bloomberg, I know that something's going to happen because these kind of news are affecting the prices. And what I've seen in a couple of research papers the people are playing with, so they define, for example, 10 words, and then they find the most similar 10 words to those 10, and they start making this iteratively until they get 1,000 words. And they make those 1,000 words as a bag of words, right? So now you have 10,000 words to check. And if a given text has some of these words, then it will be marked as, let's say, 1, right? Which means the presence or non-presence. Then you can, for example, so this is one way of like extending your feature set. Second way of extending your feature set, just take the, I don't know, last tick prices of a given stock and take the first differences, second differences, or some percentage changes, right? Whatever is informative for your use case, and then start building your feature sets like this one. You can also do the same embeddings for documents, the whole documents. So now you don't need to work with the words, but you're working with the documents. So here what I'm really doing, I'm creating an encoding for each sentence with the size of 5. And then for each document, now it's going to be represented by this vector. So now I have 5 floating numbers in that vector, 3 sentences, 3 vectors there. So you can do the same for sentences, paragraphs, the whole documents. Cool. So what else we can do? And in my own research, like the personal research, I use, of course, Watson services because I was working in the team who built Watson machine learning service. And we also have different services to work with the textual data. And one of them is Watson natural language understanding. And it allows you to uncover insights from structured and unstructured data sets. Of course, it gives you the sentiment, and it works with multiple languages, which is, of course, very advantageous when you're working with the different languages. And the second, Watson machine learning, the service that we built allows you to manage the whole model's lifecycle. So you persist your models, train, deploy, monitor, maintenance. You can do it with the Microsoft Azure, Google Cloud Platform. So in each and every platform, you have some differentiators, right, that makes that platform stronger than the others. And for the Watson machine learning service, it's about like really end-to-end development and deployment and the monitoring the performance and taking some automated actions if your models, for example, starts to perform worse, right? So let's see how I can use this service. So you usually receive this kind of text, right? You scrap the web periodically, and you get a bunch of text, you know, like this. And now you can clean this text by using like simple cleaners. Now I have a simple wrapper there. It's just replacing some of the parts, and then it gives me the clean text. Now I have this text from that article. Now what can I do with it? So by the way, one of the things that I was doing when I was scrapping these news, I was looking at the link, and if that link includes one of these ticker values like IBM, Google, or Microsoft, then I was tagging it, okay, this is my target article to be analyzed later, okay? And what I was doing, just grabbing S&P 500, and then taking the tickers from there, and just, you know, doing a simple check. And this is how I really set up my account, credentials, and then now I would like to send this text to Watson Natural Language Understanding Service. So this is my link. I have the IBM in there. So this was the article. It was about Warren Buffett was cutting its shares in IBM, and I was trying to understand how it was affecting the prices. And this is the example how you make a request to the service. So I would like to extract entities, the sentiment, the keywords. I would like to get the category of this text, also know about the concepts and the semantic roles. So let's see what I get. So here is a simple JSON that is returned from the service. And what I'm really interested in this one is the entities part. And here I have company-related information. right? So I have the IBM ticker in the link. Now I catch this entity, and now I have the label negative, and I have the score, the sentiment score. Other bunch of things that I can use, but now it's enough. So this is the entity that I'm interested in. Then I extracted the label and the score, right? So now this is ready to be added to my feature set. And my feature set is basically, I can hash, right, the text. And what I can do, I can add the label and the feature set. Like I mentioned, you can extend this with a bag of words, including the important words. You can add price series, and a bunch of other statistics. Okay. And this is the most simplistic algorithmic trading system that you can have, right? Data sources come in here. You have the modeling part, alpha, risk, and transaction costs. So this is where you're really backtesting your strategies, right? If they're profitable or not. And the risk is controlling your exposure. At any given time, for example, any of my position cannot exceed 1% of my portfolio, right? So by this way, you are limiting your risk exposure. And then you have the transaction costs model. So how much does it cost for you to get into a position, get out of a position? If you're paying the commission or just the spread, right? These kind of things. And of course, you create your portfolio, and then you execute your trades via broker or direct market access, if you have, right? And that broker could be, for example, I use Oanda for FX and interactive brokers for general like equities. And DMA is like if you have a direct access to the exchange, which is really costly, and I think it's not even available for individuals. So let's see what else. So that alpha is very simple. The beta, so you have beta and the alpha. So the beta is attributed to the market conditions, right? So if, for example, you're investing in an S&P 500 index, and that index gives you a 10% return, and if your beta is 1, you expect to get 10%. So it's not your skill or added value, right? So that is the value the market already is giving to you. But if your benchmark returns 8 and your strategy returns 17, then your alpha is 9%. It is also, could be phrased like, whatever the market does, I wanted to make money. Yeah, I don't care if market goes up, market goes down, I wanted to make money in every situation. And that's, this is the holy grail of quantitative investing. So the finding alpha is like a huge quest, so everybody is trying to find it. And the machine learning part, traditionally it's been like support vector machines or logistic regression were applied to these kind of situations. And the sentiment analysis were kind of tricky because, you know, you have these contradicting examples. Like depending on the context, then the meaning can change quite a bit. So here, this is one example, another example, and sometimes people are using a lot of different wordings to mean the same thing. Yeah, like not the best instead of average, vice versa. And we talk about it. The ML needs vectorized numeric inputs, and here you see the data, right? So you have the feature vectors and you have the labels, the y. So you're trying to learn this function f, parameterized function. Like you have the model weights that will give you the predictions, and of course you have the loss function that measures the output of your model with the actual label. I put a small list. These are the algorithms that are commonly used in finance, like if the machine learning is involved. Recently, we have more and more like ensemble methods are used. Also, in a lot of Kaggle competitions, right? If you're interested, you will be seeing these algorithms. And this is a simple example of creating machine learning pipeline. So now you have all these feature transformers, and then you have the estimator, the classifier at the end, and you have a bunch of parameters that you would like to optimize. And this is the number of lines that you should actually write to train this pipeline, right? And once you have this pipeline now is a deployable asset. Now you can deploy this pipeline to any service and make it operational, meaning that you can make post requests and start consuming the predictions. You can extend your pipeline make it more, let's say, advanced, you can write your own transformers and estimators. You can extend the scikit-learns or Spark ML's transformers and estimator classes and do whatever you would like to do with them. For example, text, you can write a transformer just to extract paragraphs, right, if you're interested in that. And look at the NLP side of things. What I see more and more that, for example, a special type of recurrent neural networks like LSTM, they're being used in sentiment scoring, right? And this is just one more model to the ensemble of models that they're using. So you might have multiple models. Let's say you have, I don't know, ensemble methods, you have some simple linear models, and then you have also another input coming from the sentiment model. So then you're just having, you're weighting the scoring coming from each model and then producing the final scoring, then it actually feeds your strategy part, right? If what you would like to do with the sentiment with a bunch of other scores coming from other algorithms. So I believe these are told many times, but it deals with a chain-like nature. So it's like time series. So there's some sequential nature to the data that you're working with, like a text data, like a time series data. And it predicts, of course, the events based on previous ones. It's like, I don't know, what is the next word, right, in a sentence coming, or what will be the next price in a given time series, price point. And of course, they have loops in their architecture, so they're just kind of mimicking the memory. So every time you're trying to predict the next step, it's using information from all the previous steps, right, based on how they are weighted in the sequence. And the special type LSTM. So this is a basic architecture. There's a great blog, by the way, called GitHub.io. Just if you go there, there will be a bunch of neural network, like entry-level tutorials that will get you into the field. So here, so you have a different time steps, and then actually every time step is using some of the inputs from the previous one. But it was very simple architectures, and it wasn't able to deal with the long-term dependencies, right? In terms of long-term dependency, I can give you an example, let's say, in a text modeling. I can say, I'm from Turkey and I love to eat Turkish food, right? And if model is trying to predict, I'm from Turkey, I love to eat, what would be the next, right? So we need a bit of context here. So we need the information from the previous sentence that needs to understand that I'm someone from Turkey, so it can infer that I should love the Turkish food. And it's the same with the time series, right? So in time series, we always have like autocorrelation. So it means that the values in the time series are serially correlated to the past values. And that's the structure that we would like to uncover. And that's why we are using long short-term memory networks. It can handle long-term dependencies, remembers the context for long periods of time. And it has a structure called gates. And now through these gates, right, so it basically, like the simple has three different gates: input gate, forget gate, and the output gate. And all these gates actually managing how the state of the cell will be managed. So how much of the information coming from the previous state will be used in this state, right? How much of them I'm going to forget, and how much of it is going to be passed to the next state. And by having these loops, they manage to also effectively address the issue of long-term dependencies. And this is not something new, guys. This is like 20 years old idea. And actually, most of the ideas in neural networks are, let's say, they're really old, but we have more and more cheap commodity hardware that now we are able to test those and build better ones. So, do a quick check. So, just to encourage you a bit further, if you would like to implement your own LSTM-based architecture. So what I'm really using is Keras, very easy to use library. So what I'm doing is to tokenize the sentence. So tokenization means like splitting sentences up to its words. And then I'm padding it padding means if one sentence has 13 words and the another sentence has 25 words, now I need a fixed length input. So I can do the padding parameter to 50, and it will fill all the parameters remaining with zeros. Like you see here, what's happening here. So these are referring to the indexes of each word in the sentence, and all the zeros that are basically padded. If I have if I wanted to have, let's say, 100 size vectors, then it just fills remaining with zeros, and I have the training labels as well. So the previous cell and this cell, you need to code to have a LSTM-based architecture. So you have the sequential model here. Then I add an embedding layer, and then I add a LSTM layer and the dense layer for the outputs. And of course, compile the model here. You see the very simple model as a model summary, number of parameters, and a bunch of other details, which are not important now. But this is really easy. Now, if you go and train this model, now this model is ready to be consumed. Now you can use the services that I mentioned previously to actually operationalize this. And if you are an application developer, right, you can start building your web applications or any other type of application on top of it. So I'm going to show you how it's done in the service that we've developed. So I have my service credentials here. What I'm really doing is creating a client object from my credentials, and I just persist my model, just invoking the store model, right, from the repository module. And I'm going to get the unique identifier for that model. And just to deploy this model, I invoke create coming from the deployments module, and I'm going to get endpoint like this, right? And now I can hit this endpoint with the proper input data, and I can start getting predictions back. So this is my scoring data. It's just a bunch of numbers. Now I like the score, for example, this one. Now I just invoke the score, and then I get the value. So it's, I don't know, positive sentiment or negative, whatever. So you can deploy any framework like scikit-learn models, Spark ML, XGBoost, we support TensorFlow and Keras. You can operationalize any machine learning model. We have, of course, GPU-based architecture if you would like to distribute your training to save some time. So just to wrap up. Perfect. Just to wrap up. It's based on public and sentiment opinion, right? The whole idea of this talk was just to understand how we can encode the textual data and enhance our feature set. And I mentioned a bit of sentiment opinion. It's mostly about market indexes and stocks because the availability of the data, right? You can easily access this type of data. And the Twitter is very popular of data source for this kind of analysis. And another sources could be like blog posts, news agencies. You can track search engine queries about particular assets. Modeling workflow is very simple. You have the data processing steps that we've mentioned, and then the modeling, and you have the pipeline model. And in a bit more detail, you have all these basically techniques that you can, try it out, and then you have all these different modeling techniques as well. I put this list here in case if anyone would like to also learn about hyperparameter optimization. A lot of different approaches, and then get the pipeline model, and this is the sample application architecture that you can have. So you're just collecting the data here. You are doing a bit of data pre-processing here. If you'd like to deploy it in a near real-time environment, you can use something like Kafka. We have IBM Message Hub, and then you can deploy this model in a streaming fashion. It's a streaming workload. You can also store the same data sets in the cloud object storage, and then you can also do some batch modeling, right? So this is kind of your research environment, testing environment. You're just developing models. Close. Strategy, portfolio, and through portfolio you execute your trades in the markets. Thank you.
Okay, thank you. It was really interesting. really personally interesting because it's money. Everybody likes money.
Thank you.
And if you put deep learning inside, it's even better. So, where are some questions? We can have like two questions. That's more than two. You, okay.
So you showed how you can build a lot of features which are continuous variables, but I imagine it may be useful to know, for example, if a document is an article or a tweet, which would be a categorical non-ordinal variable. How would you include that in your model?
So, I mean, this is basically taking one source as a feature building, let's say, technique. So if you're working with the articles, that you just work on the articles. If you're working on the tweets, you are working on the tweets, right? So,
okay,
so
but
basically,
then any categorical variable that could be like, I don't know, something that you can extract which is discrete and non-ordinal. Is there any way to kind of combine it with continuous features?
I mean, so far I work with the continuous features, so I'm always like, using this numerical vectors and the continuous variables. So I don't have any like particular experience in that, but you can definitely try a lot of different things with the categorical variables as well. Because usually what you're predicting is like category at the end, so up or down or steady. So you might as well just use the categorical variables in your feature set, but dismiss all the numerical features. So this is a highly experimental area. Like you can do whatever you really want with your feature set. And I'm coming from background from the like quantitative finance, so we were always using the time series, and now I'm incorporating the text when I'm transforming them into numerical features as well. Okay.
Thank you. We have one more very fast question. Okay, now there is none. Okay. Alpha question, okay.
You said you're using sentiment score as a feature, and the sentiment score is already kind of pre-calculated by the IBM Watson.
Yes. So
it's kind of uncertainty which you also kind of introduce into your model because you don't know how exactly this sentiment model was trained.
Exactly. So the reason that I showed it, like for the people who are not familiar with the modeling part of sentiment, so they can easily get that score like without even like getting into the architecture building, right? Because in other case you need a team of the scientists just to build those models for you, and then you can after that consume that. But as majority of people are developers here, how they can use like the additional services to save time and then get into the let's say that feature building on their own.
Okay, thank you.
Thank you. Thank you. Okay, thank you very much.